Good morning, students. So today's lectures we're going to discuss about series LR circuit. Series LR circuit. So in this circuit there are two parts: growth of current and decay of current. Previous lectures we already discussed about what is L, what is R, what is C. All these parts we already discussed in previous lecture. So today's lectures we're going to discuss about what is series combination of LR circuit, and there are two types: growth of current and decay of current. Using the circuit diagram we find out the expressions for growth of current, decay of current, and some cases related to series LR circuit. Okay, so first I draw here a diagram for LR combination. L means inductance and R means resistance. So first I draw the diagram. See, this is the L and this R. Both are connected in a series combinations. Here E, that will be a cell. It provided the voltage to that given circuit. This S is represented as a key of that circuit. When key is closed, then the current is starting to flowing. So this L and this R, this will be E. So the circuit name is the series LR circuit. Series LR circuit. Series LR circuit. Okay. So now see, a source of EMF is connected across a series combination of inductors, that will be L means inductors, and resistance. Okay, let L be the self inductance of the inductor coil, and R is a total resistance. So here I mentions L is what? L is a self inductance of a coil. Self inductance of coil. Self inductance of coil. Then R means what? Total resistance in the circuit. Total resistance in the circuit. Okay. So initially current passing to the circuit, it will be a 0. So initially I will be 0. Current is represented as a symbol I. Initially I is equals to 0, and when the switch S is closed, it means this switch is closed, then current is start flowing in the circuit. So let I be the current, instantaneous current. Here I introduce, let I be the instantaneous current. Instantaneous current at time t. Time t. So the EMF equation for the circuit, it means electromagnetic force equations for this circuit, it will be written as, see, as like this: EMF equation for the circuit, EMF equation for circuit using Kirchhoff's law. You know Kirchhoff's law. This part already done in a previous standard. Uh, so here we apply Kirchhoff's law, and we also use some differentiation rule for this. So now we write equations. E is equals to L di by dt plus I into R. This is equation first. Okay. So here write electromotive force or electromagnetic equations for this circuit. It will be E is equals to L. L means self-inductance of the coils, and with there is current with respect to time, that will be, let I be the instantaneous current at time t, and I into R, that will be a voltage according to Ohm's law. You know Ohm's law. Ohm's law is what? That will be V is equals to IR. So same will be apply here, but here we use a small I because small I is represent the current it is flowing through the circuit. Okay, so A is equals to L di by dt. So now using these equations, we find out the values of di by dt. So how to find this value di by dt? This IR is here positive, it goes to opposite side, then it will be negative. So we get L di by dt is equals to E minus I into R. Okay, so now this L is here multiplied, is goes to opposite side, that it will be divided. So we rearrange again this equation and find the values of di by dt is equals to E minus IR upon L. This also, if you common out R by L, then what happened? Here is not L are there, so we write as a E by R minus I. So now we separate out these equations, so that will be written as this part is keep here. So now we separate out this equation, that will be E by L minus IR upon L. Okay, so but we common out R by L, here is not R term is there. Okay, so that will be a divided, so that's why we write R by L is a common out, and we write E by R minus I. It is same as like this, but first I separate it out, and after that we note down this term. So now we common out minus sign, then what happen? It will be minus R by L into I is a positive and minus E by R. If you multiply by minus sign to this equation, then we get again this types of equations. So that's why minus sign is common out. So now we again modified these equations. So how to modify this? So di by dt is equals to minus R by L into I minus E by R. So this I minus E by R is totally multiplied to this equation. It goes to opposite side, then it will be divided. So which types of equation we get? See here, di upon I minus E upon R is equals to minus R upon L into this dt is here divided, is goes to opposite side, then it will be multiplied. So we get such a types of equation. Okay, so this is equation number second, this is equation number 3. Okay, so now we find out the solution of that given equation. So how to find out the solution? Simply we take integration of this equation, taking integration, then what happened? So therefore di, integration of di I minus E R, this R minus L is a constant, so it is out of integration, into dt. So 1 upon I minus E by R, integration will be ln of E by R. So integration of this term, it will be what? I minus E by R is equals to minus R by L into T plus C. C is what? C is a integrating constant. C is integrating constant. So now we find out the solution of that equation. So how to find? See this. So what is our equation? That will be ln of I minus E by R. I write again this because it is backside, R minus L into T plus C. C is integrating constant. So now we have the values of I. So how to find the values of I? See, there will be. So we use initial condition. Initial condition is what? For starting condition, that will be time is equals to 0 and I is also equals to 0. For first condition, here I reference this condition. Initial condition of I is equals to 0 when that time is also equals to 0. So we put this condition in this equation. So this is equation number 4. So reduces to equation 4. Reduces equation 4. So what we have, we put t is equals to 0, then this total time is 0. So we get c is equals to I is equals to 0, then we get ln of minus E by R. Ln of minus E by R. I already, I think, give here equation. So ln of, we substitute this value of c in for equation, this equation as a 5. Here I write statement put 5 in 4 we have such a types of equation that will be put ln of I minus e upon r into minus r by l into t plus value of c, it will be ln of minus e upon r. Okay, so now thing is, this term is here positive, it goes to opposite side, then it will be negative. So ln of I minus e upon r minus ln of minus e by r. This minus is inside the bracket is already because of these terms, and this is a positive term total. So this positive sign is go to opposite side, then it will be negative. So that's why we write these types of equation. So is equals to minus r upon l into t. So according to rule, you know about the rules. Most of the times I tell about this log a minus log b is equals to what? Log of a by b. The same rule we apply on this equation, then what we get actually, ln of I minus e by r upon minus e by r is equals to minus r by l into t. Okay, so now we remove the log of this term, removing log, then what happened? Removing log, then this term is goes to e raised to power. In previous chapters we already discuss about, in differentiation chapter we discuss about, if you remove the log, then the next term is will be go to e raised to power. So I minus e upon r minus e upon r is equals to e raised to minus r into l into t. Okay, so then next term is what? This minus e by r is there divided, it goes to opposite side, then it will be multiplied. So I minus e by r is equals to minus e upon r e raised to minus r by l into t. Okay, so using this equation we find out this value. So now this minus e by r is here, minus, it goes to opposite side, then it will be plus. So I is equals to e upon r, because this term is comes to this side, that it will be positive, minus e upon r e raised to minus r upon l into t e raised to. Okay, so now e by r is a common on both these equations. So what we get? E by r is here, e by r is here. So we common out these equations. So I is equals to e upon r 1 minus e raised to minus r by l into t. Okay, so let we find out the maximum value of current. So that will be e by r is equals to Im. Let e by r is equals to Im, then value of I is equals to Im. Equation 6 reduces to, if you put e by r is equals to Im, then what happen? I is equals to Im 1 minus e raised to minus r by l into t. So this is the value. The equations are given here. So now this so here I represent another functions. So now L by R is a what? Dimension of time. Dimension of time. So that's why this L by is represented as a function, that will be 2, and equation 7 becomes here saying about L by R is equals to 2. It means value of L upon R is 2, but here R upon L, so it will be 1 upon 2. R upon L is equals to 1 upon 2. We substitute this value, then this t is here multiply, so minus t upon 2. So we get the equation that will be I is equals to Im 1 minus e raised to minus t upon 2. So this is our final equation, and if you put value, it means time and time dimension both are same. t is equals to tau, then we get values of I will be 0.63 into Im. Why? Because we put 1 minus e raised to minus t and t are same, so cancel. E raised to minus 1 will be 1 upon 2.71 naught, and if we subtract this, then we get I minus I is equals to 0.63 into Im. This is the values of current. So hence time constant is defined as time taken for the current to rise 60% of its maximum value. So meaning of this word, current is rise by the 60%. If you multiply by 100, then we get 63% of its maximum value. Okay, so this is the expressions for growth of current. Here we are discussing about there are two types, growth of current and decay of current. Okay, so this is the one part is completed, that is the growth of current. So this is the expression of the growth of current. I mentioned here the thing. Uh, this expression is a growth of current. Okay, so there is a decay of current we discuss on the next lecture. Okay, thank you. If you have any doubt regarding that topic, then you can send your comments on comment box. Thank you.